Hello guys, welcome to Small Somewhere Math Tutorials. So the today's lesson will be doing the midpoint theorem for Euclidean geometry, grade 12. So the midpoint theorem is a special case of theorem 1, right? So mostly whenever you use this theorem, the reason is the midpoint theorem. That's the reason. So okay, you see how do we write that reason? So now just know that if, okay, note these things, if AB is equals to PC and AD is equals to DE, therefore by default, then by default or automatically, then by default BD is going to be parallel to CE, right? And if BD is parallel to CE, therefore a BD, the length of BD is equals to half of the length of CE. Okay, I'll explain it again. Okay guys, from the first diagram you can see that AP is equals to BC, it's given, right? And also AD is equals to DE, and they are also given, right? Therefore, if you have a scenario like this, then by default you are allowed to say that BD is going to be parallel to CE, right? So therefore, meaning BD now is parallel to what? To CE, and then BD is half of the distance of, and BD is half of the distance of what? CE. So meaning if we have 10 here, for instance, therefore the half of the distance here is going to be what? It's going to be 5, right? You can even calculate it. Let's say you have BD 1/2 into what is our CE? It's 10. What is half of 10? It's going to give us 5. You see, this is how we do it. So just capture it that way. Now we come to the second one. From the second one, we can see now we are only given the parallel lines. Right? So from the parallel lines, we see that, note, if BD is parallel to CE, right, then by default AB is equals to PC and AD is equals to DE, right? This is the converse of what? Of the midpoint theorem. So the reason of this, whereby you're going to say B is equals to BC, is the converse of midpoint theorem. Yeah, mostly they write it like this. It's the converse of the midpoint theorem. So this one, whereby you're going to say B is equals to BC, then by default BD is equals to CE, we know it's going to be what? The midpoint theorem, right? So after knowing these things, we now know that obviously like we said, BD is equals to half of the distance of what? Of CE. So knowing these things, guys, they're going to help us a lot. And remember, if you know that, okay, whenever AB is equals to BC and AD is equals to DE, then by default BD is parallel to CE. It's going to help you a lot, mostly whenever you're going to prove like more similarity or one of those kind of things. Oh, so now let's continue and sort about this thing. Let's continue and let's do the proportionality theorem, so that, yeah, let's do the proportionality theorem. After this one, after the proportionality theorem, we're going to do some other examples so that you can see how do we apply this knowledge that we have for midpoint theorem. This is how the midpoint theorem it is. The first one, if AB is equals to BC, then AD is equals to DE, then by default BD is parallel to CE, therefore BD is half of the distance of what? CE. Therefore the inverse of it says what? If you are given that BD is parallel to CE, therefore you are allowed to say that AB is equals to BC and also AD is equals to DE, right? So now let's talk about the proportionality. Okay guys, so now from this, so I want us to talk about something before we can do the questions. As we can see that we have A, B, C, and A, B, C, A, D, E, right? So we know that AB all over BC is equals to what? AD all over DE, right? And the reason is line parallel to one side of a triangle, to one side of a triangle, right? And we also know that you can see, you can just play with them the way you can. AC is equals to BC, where Y is equals to AE is equals to DE. It's the same thing, same reason. You can play with them the way you can. So I want us to talk about something. So remember, now let's go, like we talked about the similarity. I want you to check something. Sometimes you'll be given something like this, which is A, B, C, D, E, and we can see that BD is parallel to what? To CE, right? So from this, we can see now we have two triangles, which is triangle ABD and triangle ACE, right? So if we're instructed to what is that? Okay, if we're instructed to guys, what's happening with me? Okay, sorry for that. Okay, yes, as we are given triangle, as we can see that we have triangle ABD and triangle ACE, and the question comes that it says prove that triangle ABD is equals to triangle ACE. What are you going to prove? Okay, in fact, it's going to say prove that triangle ABD is similar to triangle ACE. So how do we prove it? Now check, we have the parallel lines. So don't forget that. Remember about parallel lines, we talk about what? The fan. It's fan. Yeah, fan. Where F represent what? The corresponding angles. We know that is this angle and this angle. And then where U represent what? The co-interior. and where C, whereby it's like N, it represents what? The alternating angles. So therefore we need to check those things. So like I said, if we are proving that the question says prove that triangle ABD is similar to triangle ACE, the first thing that we do is to do what? We first equate the first alphabet with the first alphabet of the first triangle and the second triangle. Therefore it means we're going to have angle A is equals to angle A. Then we come to the second alphabet of the first triangle, which is B. We write it down. We check the second alphabet for the second triangle, which is what? It's C. And lastly, you can see that is D. And then here it's going to be what? E. If you didn't go through the tutorial video about the similarities, you can go through it with this. We did discuss about this and made few examples, so you'll see why we are doing this. So now we do what? We give the reasons, right? Now we give what the reasons. A is equals to A. Yes, this one is common. You can just B is equals to C. B, okay, angle B. Which angle B? Okay, angle B is equals to angle C. Do we know there is a? Yes. Remember, from we have BD and CE, and from BD and CE, the parallel lines, right? So meaning this angle is equals to this angle is equals to this angle. The reason is corresponding angles, right? And also this angle is equals to this angle. The reason is corresponding. Can you guys see it? So B is equals to BC. The reason is going to be corresponding angles. Therefore, you state the lines which are parallel to each other. Therefore, BD is parallel to CE. The third one, even though you really know like that DE is equals to DE because of the corresponding angles as we have the parallel lines, you can just say the third angle of a triangle. Therefore, we proved, therefore, we should say triangle ABD is similar to triangle ACE. The reason is we proved its angle. So meaning it's angle. Right? Therefore, we are done. Yo, what's going on here? Okay, guys. I hope you can see that this theorems like the interlink that one. So if you know that one, if you know all of these angles now, then you're going to be fine. But then the most important part is to do examples. So if you would like us to be in my group, you can leave your number from the comment so that I can add you to my group, so that whenever we do the examples, you can send them and then I'll check them and then we'll take it from there. So yeah, this is what the midpoint theorem and the proportionality is all about. So we saw that, okay, from the midpoint theorem, we went to the proportionality theorem. From the proportionality theorem, now we are asked to prove that the certain two triangles that are similar. But then we know how to do that, right? So lastly, guys, I want us to talk about something, but then I'm going to make a video about it because, okay, I can see the duration now. I'm going to make a video about it whereby mostly they like to use it whereby they say prove that, for instance, b squared is equals to, they can say ab multiplied by let's say TE, something like this. They can say like prove this, B is equals to AB multiplied by TE. So if you follow my video now, after this I'm going to do a video whereby talking about something like this and the strategies of how to answer the questions for grade 12 Euclidean geometry. So please guys, don't forget to comment and subscribe, and also like guys, like. So thank you for today.